Hey guys, so welcome. Today I'm going to solve another Leetcode problem called product of array except self. So I'm doing this problem live without having seen it beforehand, so please be patient with me. And the way that I typically solve problem is the first thing that I typically do is in the comments section of the code, I try to break the problem up into its essential components, and I try to answer each component before deriving the final solution. So let's read the problem statement. Given an array nums of n integers when n is greater than 1, return an array output such that output I is equal to the product of all elements of nums except nums I. Okay, so let me quickly read these problems. Okay, so let's break the problem up. So input, output, and questions. Let's see. Clarifying questions, brute force solution, optimal, identify bottleneck, optimal solution. So let's first identify our inputs. So we are given an array. Okay. Array nums of n integers and all numbers, okay, and n are greater than 1. N is greater than 1. So this tells me that an array will never be empty. It'll always be some number of elements that's greater than 1. So our output, so what is the output? So we are also returning an array such that out. So let's name our variable. So our input array is called nums, and then according to the problem statement, output is called output array. The variable name is output, and the constraint is that our output I has to be equal to the product of all elements of nums except nums I. I see. So this makes a lot of sense. So this essentially means that output I equals to output 0 times output 1 times ... times output so what is the size of this? N minus 1 except I itself. Okay. So let's make this a little better. So essentially what I'm trying to say here is that the value output I equals to output I plus 1 times output I minus 1 something like this, ... n minus 1. So this makes the problem much clearer when we write it out like this. Okay. So now let's ask any clarifying questions. Are there any edge cases that we have to consider? Are there... So let's see. So we are given an array of nums we are given an array nums of n integers where n is greater than 1. So this means that array is never empty since n is greater than 1. Another thing that we have to consider is that so the problem statement doesn't say anything about the numbers, so I'm assuming that element at Ri can be greater than or any integers, essentially positive or negative. Okay, let's see. Okay, so from then on, let's think about how we would do it in a brute force manner. So a brute force way of doing this is to essentially let's see, let me think about this. So a simple way of doing this is to create a copy. Okay, essentially store a solution into another array. So essentially we'll just create another copy of the array and we'll store that into that array. Store a solution into another array, and what we'll do is we'll traverse from left to right n times for each element. So we'll traverse the array n times. We'll compute product as we traverse the array from left to right n times. We'll also compute the product of all elements except I. Okay, so you can probably guess that with this solution the runtime is going to be O of n squared, since we are traversing through the element n times and there are n elements that we have to traverse through, so n times n becomes n squared. Okay, so here so let's look at the problem statement again, and if you notice we have to solve it without division. So this sort of gives us another hint. So there must be another way of doing it with division. Okay. So let's put that under our special restriction. No division. So the algorithm has to be O of n, runtime. However, it doesn't say that we have to. Okay, the following follow-up question is, could you solve it with constant space complexity? Okay, the output array does not count as extra space for the purpose of space complexity analysis. Okay. Sorry about that. My neighbor's dog. Sorry about that. I was waiting for my neighbor's dog to stop barking. So let's continue with this problem. Okay, so let's see. So now we are covering any special restriction that we have to think about. Okay, so it seems here that output array does not count as extra space. Okay, so it seems that it's okay for us to initialize an array for output array. Okay, so now now that we have come up with a brute force solution, so let's identify any bottlenecks. Okay, so obviously here the bottleneck here is that we have to traverse the array n times. Is there anything? So let's ask some questions here. So okay, so we have identified our bottleneck, which is traversing array n times. And why is this a bottleneck? And the reason why this is a bottleneck is because we are repeatedly looking at passing the same elements, right? So now the question becomes, is there anything we can do to maybe possibly pre-compute the array such that we don't have to do repeated works? Okay, so let's look at an example here. So we have this example. So to answer that question, so let's look at an example. We have 1, 2, 3, and 4. And the output is 24, 12, 8, and 6. Okay. So let's break it up. So let's make a new section here. Example, right? So we have, so for output at 0 equals to array of 1. So this example is pretty easy. Okay, 0, 1, 2, 3. Output at index 1 equals to array 0, array at index 0 times array at index 2 times array at index 3. So the output at index 2 equals to array at index 0 times array at index 1 times array at index 3. Output at 3, 0, 1, 2, 3 equals to array at index 0 times array at index 1 times array at index 2. Okay, so now if you look at this, let's see. So if you look at this example, we see that, let's see, so we can see that we are multiplying array at index 0 3 times. We are wasting computation here, right? So we see that array 0 times array 2 also happens here. Array 0 times array okay, so let me rephrase that. Element at index 0, index 0 times index 2 also happens here. Index 0 times index 2 here for output of 3. So it seems to me that there is a way for us to pre-compute the product, since there are duplication of work here. If you look at the breakdown that I just have written out, so now the question becomes, how do we store the pre-computation? And right, And one way of doing it is through, so let's ask the question, how can we store pre-compute work? And so this goes to our hint here. It says no division, so what we could have done is to compute total product, and for each element divide that element out. But obviously we can't do that because of this restriction here. So that's totally out of the our options of solving this problem. Okay. Anything else we can do? Let's see. Array I times array 2. Let's see. If we are given the option of using extra space, what we could have also done is to what we could have done is to compute left to right lookup and right to left lookup. And essentially what I mean by that is we could pre-compute our work by traversing from left to right, and let's say at index I, our left to right lookup would be 1, and then when we get to here, our left to right product is 1 times itself. When we get to here, our left to right product is 1 times 2, and then we pre-compute the product into left to right and right to left, and then after that pre-computation, we then, for each element, we simply have to do left to right lookup and right to left lookup and multiply the two sides together, the left to right and right to left for each index. However, that option is not available as we are not, as the problem statement says, we cannot use extra space. Okay. But it's not a strict restriction. Since I cannot think of any other ways of doing it with O of n space, why don't we explore that solution? Okay. Okay, so let's explore that solution. So let's pick that solution, right? Using extra space, compute left to right lookup, compute left to right lookup, and right to left lookup. And what I mean by that is here, for example, okay, I think you know what I mean. So let's implement that in code. And with this implementation, we'll also need an additional of 2 of n space, because we have 2 arrays that we have to store. One array for left to right product and the other array for right to left product. Okay, so now let's explore this solution. So the first thing we have to do is initialize our solution array. So let's do that. Let's see. You know what? We can simply reuse our nums. Okay. Actually, what we need here is right, meaning we can just reuse the input array, right to left. Okay, so let's call it right left. And we'll initialize it to length of nums. And in our comments here, we'll do pre-compute products. And finally, we'll compute solution here with our pre-compute arrays. Sorry about the noise. Okay, so now let's see. So now all that we have to do is for each element, okay, let's see. Actually, let's do this. Enumerate nums. So let's initialize our current products to 1, and then what we'll do here is equals to cur equals to cur times val. And what I'm doing here is that I'm storing current product to our right to left array without itself, and then at the end of that we'll update our cur with the current value multiplied to it. And we'll do the same for right to left. And in Python we can reverse, let's see, this is a little tricky. So we want to do this in the reverse order, and so let's see, we can do it like this, reversed, and we do the same here, left, right, or I equals to cur and cur times val. Okay, so before doing anything else, we should do a quick test. So now I'm going to print out the arrays to see if it's doing what I expect it to do. So let's run the code and see what it gives us. Okay. let's see, it seems that I'm not using enumerate correctly. Let's see what's going on here. List index, assignment index out of range. Okay, so let's look this up quickly. Python enumerate. Okay, so the first one is going to be the index, and the second one is the value. Okay, so I have this in the reverse order, so it's indexed and then value. So let's try this again, see what it gives us. Okay, so we are getting the same error here. Let's see. Enumerate object is not reversible, so we cannot do that here. Okay. Okay, so instead of doing this, what we could do is here. So for now we just do something like this. Let's see. Python range reverse. Oh right, we just reverse the range. So we just do it like that for now, and then we'll do something like this. Okay, so doing that should fix our problem. So as expected, at index 0 the product is 1, 2, 12, and then from the reverse side, the product at index 3 is 1, 2 is 4, and so on. Okay, so now all that we have to do is put the two solutions together. Goes to okay. You know what? So actually this is left to right. So let's correct the naming, and this is right to left. Okay, I think we are good now. So all that we have to do is combine our left to right solution to right to left, which contains the value of products from left to right without excluding itself, and also right to left excluding itself. And now we can simply return the input array. Running this should give us the right solution. Expected, okay, and it's not. It's interesting. Let's see. It seems that our last I apologize for the noise. It's a little loud. Oh, okay, I see a problem here. Yeah, somebody's mowing the lawn and the dogs are barking. Okay, so our solution should be correct now. So with this solution, with extra space, we have a sheaf O of n runtime and O of 2n space. Okay, so let's try to submit our final solution and accept it. Okay, thank you for watching, and I apologize for the noise in the background. I have no control over that, and see you next time.